I love logarithms. Y'all will probably hate it. Logarithms help you answer questions that you normally can't answer. Like a logarithm helps you answer 4 to the x is 509. Most people can answer some of the simpler things. These are exponential equations. Most people can answer an exponential equation if 3 to the x is 27, what's x? That's 3 times 9. This is an exponent. It's 3. 3 times 3 times 3 would be 27. So x is 3. And again, most people can probably do this one. It might take them a little bit longer.
Let's say 3.
Nope, 4 cubed is 64. It's not 3.
5.
Nope, it's 1024.
4.
6 is getting farther away.
4.
It's the 4th power.
No.
Turns out that 4 times 4 times 4 times 4 is 256. So x is 4. That's not going to help you figure out the 4 to the x is 509 thing, is it? No, it's not. Okay. I'm going to go ahead and write down what you have in that blue box first, then we'll go back to that one. Okay? So in that blue box, there's another black box there, and it's got the formula, it's got the conversion from a logarithmic to an exponential equation or vice versa. It says a logarithm of base b, argument a equal to e, is equivalent or has an equivalent inverse of b to the e equal to a. You should probably write that down, because if you can't get this, there's no way you can do logarithms ever. Shouldn't. That. Don't like this, I can teach you the way Joe Robin Buckley taught me. It was horrible. It was log base x
We never learned
to the
this in
y
8th
equal to
grade.
r.
That's why.
You did not learn this. I had Joe Robin Buckley in 1997. Wichita High School.
Oh. Well, she now teaches in middle school in 8th grade.
I know. Again, like I said, if you don't like log is bay, I can teach you a different way. I like log is bay. Bay is French for crap. Do not ever call your significant other your bay. It's not a compliment.
That happened for a good couple of years.
Hey, you not have those? You weren't in here, were you? God bless you, why can't you know that? Do not tune out on day one of logarithms. Now, the reason I like this is because these letters are meaningful. I deleted all that, didn't I? The B stands for base. That's a base. A stands for either answer or argument. And E is for exponent, sometimes expression. So you can look at a logarithm and you can get equivalent pieces in something that's exponential form. Because over here, B stands for base, E for exponent, A for answer. So back to this. This is 4 to the x equals 509. And I'm going to write right underneath it, base exponent equal to A. And I'm going to take that rule and apply it from right to left. I'm starting on the right, work my way to the left into a logarithm, okay? I'd have a logarithm whose base is what? 4, whose answer or argument, look where the A is
509.
509, and that's my x value. Some of you guys in here have done really well on form quizzes. You might actually know enough to actually let this make sense today. somewhere on a form quiz, it's called change of base, log base b of a. There's two ways of rewriting that. I hope you're closing your eyes to picture it, Casey. There's two blanks. You can write it this way or that way.
What's that?
No,
Log A over log B.
that's it. One of them, that's good enough for today. Or for now anyways. Log A over log B. So if I want to know what this answer was, I could do log 509 over log what?
4.
4. Called change of base. You're squinting, which means you need to go to the eye doctor. The reason we have to use change of base is if we hit the log key, there's no option to put a base in. It's just log. Log 509, as Abby told me, sitting over log of 4. There's the x value, roughly 4.5. That should make sense too. That is roughly 4.5. The reason I say it makes sense is because 4 to the 4th was 256, 4 to the 5th is 1024, and we had a 509 in there. The answer would have been somewhere between 4 and 5. So it takes logarithms to answer questions like that. That's what it takes. Logarithms let you answer things that you can't normally do. That was your first intro to this, okay? Even if you don't have change of base down yet, it's fine. It's in the notes later on. Normally we don't talk about it here, but I knew that I had some kids who were doing well on form quizzes, so I talked about it. The main gist of today is to get comfortable converting between exponential and logarithmic forms. That's the gist of the day. I'm going to write this down again. Log is b. Log base b. Answer or argument a equal to e, which is either exponent or expression, is equivalent to a base with an exponent equal to what would be its answer. Now the task here is to convert the logarithmic equations into exponential form. And it's really, really easy if you'll just write down log is b above it. Then you can pick all your pieces. That's how hard this really, really is each day, because things are in nice order. So don't shake your head at this. Look at what's written and tell me what the base is.
So we're washing it, or we're putting that as the inverse of what's put down, over what's already there.
Yep, that's all it is.
Okay, 3 to the 4th.
3 to the 4th, because 4 lines up with e. And what's e stand for? Exponent. What's it have to equal?
81.
81. By the way, an easy way to check yourself here is to see if what you wrote is true. If you wrote anything that wasn't true, you didn't do the conversion right. Is what you wrote true?
Yes.
Yeah, because 3 to the 4th is what?
81.
81. If you wrote something like 3 to the 81 is 4, that's not right, is it?
No.
So just check yourself real quick. And for those of you who still aren't quite getting this, again, just write log is b above everything you see. That's all you got to do, and do a lineup process. Just do a lineup process. Grant, what's the base? 7. Casey, what's the exponent?
1.
1. What's the answer? 7. True or false?
True.
Definitely true. 7 first got to be 7. All right, you guys take a shot at C. Convert it from that exponent form into logarithmic form. Or sorry, convert from the logarithm to the exponent.
Is that it there?
I guess I finished it. Bummer. Isabel, what'd you come up with?
14 to 0 equals 1.
Is that right?
Yes.
Yes.
Is it numerically right?
Yes.
What's 14 and 0?
1.
Just making sure. How do y'all say in a form quiz that a smiley face with 0 power is 0? Anything with 0 power is 1. All right, let's rewrite D.
Base.
What's the base, Grant?
Half.
A half is right.
And your answer is 32.
Can you tell me if that's right or wrong without pushing buttons in the calculator?
I already did.
Can you tell me how to prove it without pushing buttons in the calculator?
Half is.
Got a negative exponent. What's that do to fractions? Flips it. 1/2 to the negative fifth is 2 to the positive fifth. You're smart enough to multiply 2 times 2 times 2 times 2 times 2 in your head. Is it true? Yeah, 2 to the fifth is 32. I'm glad to see you pushing buttons, but again, I'm curious if you know how to do it without. We're going to talk about a couple other things, then we're going to look at the reverse of this. All right, evaluate the logarithms by finding some number y that is equal to the log. I'm trying to make a big deal out of this because I've watched kids over the years who just don't ever understand what logarithms are. They learn how to push the buttons in your calculator and that's about it. First thing you're supposed to do when you see a logarithm is read it. You're supposed to figure out what it's actually asking you. If you can read a logarithm, you'll always know how to work with it. A lot of kids who just like to push them buttons and never actually truly grasp logarithms. They'll usually get you at least one question wrong on a pre-calc test, whether it's me or 140. In example A, I told you that log base 4 of 64 being equal to y is asking you what power of 4 brings to 64. What's the answer then? 3. 4 times 4 times 4. 64. What's example B asking you?
What power does what power of 5 does it equal to 0.2, and that's -1?
That's quick. How'd you figure that out, John?
I just put it in.
You just push some buttons and take out
I
it?
put in the exponent -1 and it went to.
Why did you guess it was -1?
Just went back because going forward it doesn't go to the decimals.
Okay, you realized that. You hear what he said? He knew that if you made the exponent positive, it would be a bigger number, right?
Yeah.
And he knows enough about exponents to realize that if you work left in negative territory, it makes it fractions. He may not remember how to do this by paper, but he knew enough to push buttons and calculator on that, so kudos to you on that. In a perfect world, you realize that that's 1 over 5. 2/10 is 1 over 5. And you realize that 1 over 5 to the first, what happens if you shift that 5 up? That
It becomes fun.
becomes -1, doesn't it? Same result.
So times the negative exponent makes them into fractions.
Times the fraction.
It flips them to where they're underneath the lookout.
Negative exponents flip. All right, C. Log base 1/5 of 125 is y. What's it mean in words? What power of a fifth equals 125? Maybe not as easy as A was, but along the same thoughts of example B. You're going to make a whole number an x, a fraction. What do you got about your exponent? It's negative. Figure it out. C is whispering to me -3. I'm
I do.
assuming she knows that because she knows what 5 cubed is. You guys know 5 cubes, aren't you?
Yeah, we do.
So to turn a 1/5 into 125, you have to raise it to the -30 power. That flips it. There you go. That's 5 cubed. What's D asking of you?
Power of 36 equals 6.
I don't disagree with that at all. By the way, the number got smaller. Didn't become a fraction, it just got smaller. The exponent could be a fraction. Here's a Marlin knows it. Leo? There you go. Leo memorized something. Said a half.
I know.
Some point in time in this class, I've tried to shove this down your throats. The root of x is x to the 1/2 power. So most likely what went through his brain is he saw 36 and he saw 6, and he knew the square root of 36 was 6. That's what would have gone through my head. Is that what happened in your head, Leo? Yeah, he just likes numbers. He understands them a little bit. He knew relationships. He knew the square root of 36 was 6, so he thought about the exponent. But he's right. The y value is a half, because the square root of 36 can be thought of as 36 to the 1/2 power. That is 6. Hope that makes sense. I'm trying to get that into your head there. Think about those two in a relationship. Square root's a 1/2 power. All right, what's up next in your notes?
Logarithm.
Okay, good. We get to talk about something, then we get to do some different examples. These are not written the same as they are in your form quizzes. Your form quiz would say log of x has an understood base of what? 10. This is written a little bit different. Log with a base 10, the 10 is understood. Understood to be there. So nobody actually is supposed to write as a final answer log base 10. They just write log of x. You have what's called a natural logarithm with that E letter there. That was Euler's number. We had that lesson last Wednesday. Logarithm base E, we don't actually write the final answer log base E of x because the E is what?
Understood.
Understood. And we actually use Euler's notation here. Use a Frenchman. Use ln of x, which is log natural. Use French. And French language is a lot like the Spanish language. You guys have taken Spanish.
Yeah.
A lot of times there are things backwards from the way we would say. Same thing here.
So you can take French course in college, do you?
You can take a French course in Westview. Prison's not big enough to have 2 teachers that teach different languages.
No, I mean like if
But
you go.
you can take French in UTM if you want.
That's what I'm planning to do. If I want to be a nurse.
I'm pretty sure you can take almost all the major languages, even in UTM. UTM's huh? If you go to a bigger university, they can teach you some of the no longer spoken languages. Sign language? I
Braille.
wouldn't think UTM's big enough to teach ASL.
What about Braille?
I think they do.
Braille is a specialty. There's only a couple colleges that left to teach Braille. Tennessee has a school for blind students.
I don't understand how.
All right, before we do this, I want to introduce some new examples here. So on your second page of your notes there, it's almost all blank. And we're going to solve for x by converting an exponential equation into a logarithmic equation. Solve for x by converting an exponential equation into a logarithmic equation. We just did a couple slides back converting from a logarithm into an exponent, didn't we?
Yeah.
Or we can go the other way around. This is actually going to gloss through the rest of that, which is no street. Because these are common logs, one's base E, one's base 10. Now, prior to today, what you had to do if you saw something like that is you'd put the left in Y1, and where would you put the right? Y2. Days when you learn how to do it by hand. Although, oddly enough, you still need to use a calculator to get a decimal. But you actually can solve for it completely by hand, you just won't know what the number is. That probably doesn't make much sense, but you'll see. So example A is e to the 3x minus 4 is 7. Underneath it, or above it, or somewhere, I'd write this form, b to the e equals a. And somewhere off to the side, maybe log is bay. That's what this is all about. Nothing more, really. So if you have e to the 3x minus 4 equals 7, what's its base?
It's
E.
E, it's a base E equation. So when you write it as a logarithm, you write log base E. Next thing would be the argument of the log. 7. It would have to equal the exponential space.
3x minus 4.
3x minus 4. I don't know if you see this or not, but what that did is that gave you the opportunity to figure out what x is. 2 steps and you'll know what x is. What's the first step? You know what to do. It says 3x minus 4. Yes, add 4. I need to wrap this 7. I usually do. The reason I need to wrap that 7 is because that 7 is an argument of a logarithm. You can't actually add that 4 and 7 together because 7 is part of the what? Logarithm. Oh, speaking of which, I'll go ahead and change that right now. It's not log base E. Ln, natural log. Natural log of 7 plus 4 is 3x. We added 4 to both sides. Divide by 3. That'll be your x value. X is the natural log of a 7 plus 4 all over 3. You actually solved for x there. Does anybody have any idea what the number is? Me either. But did you solve for x?
Yes.
Now, if you want to know the number, what do? Plug it in. You push the buttons. I wouldn't tell you to push the buttons. Make sure you can do it. I'm going to use that fraction key. Math, num, up. So that n over d is selected. Natural log of 7. Make sure you close the parentheses. Add 4, down 3.
Oh, it's 1.98.
1 point. Should go out 4 decimal places in
Oh,
logarithms.
1.981.
It's okay, we hadn't talked about that yet. But it's 1.9820. 0.9820. You do logs, please go up 4 decimals. Please go 4. Now, unless I specifically ask you to do it by hand, could you still have done y1, y2?
Yeah.
You can. Although it's not that hard to make a question up, right? You can't do y1, y2. You just say, show your work. So you have to do the algebra. All right, example B. Let's convert that thing into a logarithm. Log base what?
Log 10 plus 5.
Log base 10. Always make sure you say the base. Log base 10, whose argument is? Oh, no. Too early. Your form is b to the e equal to a. That equation is not in that form, is it? You need to isolate the base first.
So,
No, it's not. You got b to the e plus a constant. You see it? There's this plus 5.
Subtract.
There you go. Subtract 5 from 12, I think you get a 7. That's a big thing, and I've just glossed over too. I was listening to John. No offense, John, but you always got to remember to isolate the base. You're not the only kid who's going to make that mistake, is he?
that's because I didn't know it.
Always isolate the base, because the form you need only talks about having a base of the next form on the left and something on the right. That's all it talks about. Anyways, now what's the logarithm? Log base 10. What's its argument?
7
What's it equal?
equals 2x.
You see log base 10, what do you get it right?
Parentheses, and then you
Just log. Tens are what?
understood.
Understood. Look at your calculator faceplate. It doesn't actually say base 10. It just says log. So you have log of 7 equal to 2x. What are you going to divide by?
Divided by 2.
You push that in the calculator. If you want to use that fraction key, you can. There's only one thing in the numerator. I wouldn't. I would just do log 7 over 2. 4225. Yes, ma'am.
It seems quite understandable so far.
If you can get log is vague, this is easy. Boys asleep. He's lost. Everything I teach for the next week all depends on log is vague. Every bit of it. Every bit of it. Now, we're not going to do, whoops,
We going back.
we're not going to do A and B. Because we just hit the LN button key, didn't we?
Yeah.
We just hit the log key. No point in talking about those. These are probably, these two formulas are actually on your quiz. Change of base. Abby gave us one of the forms earlier. I asked Abby earlier what log of base B of A was, and she told me log of A over what?
Log of A.
Log of A over log B. Now, that particular section of your form quiz has two different forms on it. There's either log A over log B, or there's another one.
Log B over log A.
Nope, that would be something entirely wrong. It's called change of base.
Oh, Lord.
When you did it this way, don't put these 10s in, you're actually changing it to base 10. That's what you're actually doing. A very common technique is to change to base E. Still the same form, a log over log, but we don't actually write log base E. What do we write?
ln.
ln. That's my preferred form. Hopefully it becomes your preferred form. Change it to natural log of A over natural log of B. Yep.
What's
That's
up?
what you're supposed to do.
What's up?
But what you'll see me as we're teaching, I'll always put that E there. Always. I understand it's there. And you need to get in the habit of writing it, and eventually you'll understand it's there. And there's something that's a little more old school that's down here, and we'll talk about it when we get to this one. So if I want to evaluate log base 7 to 10, I can't just look at my faceplate and do it. Because when you press the log key, did you have an option to set a base down there?
No.
That's why you need these formulas. You need to rewrite these so you can actually push buttons. So how can you rewrite log base 7 of 10?
No.
Use these forms, kids. Use that one or use this one. It don't matter. Log 10 over log 7 is one of them. What's high stays high, what's low stays low. Or if you like the LN technique, which I do, LN 10 over LN 7. By the way, that should definitely be wrapped. And then you get to push them magic buttons. It doesn't matter which one you use, you'll get the same result. Most kids, when they do this, they leave off the parentheses on 10. But if they make a mistake, that's where it's usually at. If you do log 10 over log 7, you get 1.18. 3.
Same thing.
And if you do natural log of 10 over natural log of 7, by God, you get the same thing. Oh, just see what I did? What I do wrong?
Yeah.
Exactly what I said a lot of kids do. It doesn't matter if you close this one off, it's that one that's important. Because if you don't close that one off, it divides inside a logarithm. There we go. Do the same thing. Let's jump down to C. C is not something that's on your form quiz, but rewrite log base 3 of 7 into a logarithm of base 9. A log base B of A can become a log of a chosen base of A over a log of a chosen base of B. Chosen. Like an example, he is C up here. I'm choosing to change the base to what?
No.
9. Log 9 of 7 over log base 9 of 3. Say it base. Say it base.
Nice.
Base. Now, that's not going to help you with the calculator, though, is it?
No.
Yeah, like I said, it's old school. Maybe I'll come up with a homework problem or two required when I do that.
Bonus.
Hmm?
Or maybe not bonus.
It won't. I don't know. What's that to do notes next? Ah, the simplification. It's probably the hardest thing in these notes.
Oh boy.
I mean, it's not that easy.
What's the rich?
So you're supposed to simplify these expressions. Let's start off with this. That log 4, what's its understood base?
10.
10. In order to simplify something by hand, you need to set it equal to something. So I'll say it equals x. Is that equation exponential or logarithmic? It is exponential. It's a base with an exponent, isn't it? And it always starts kids off with it has a logarithm in it. It still is exponential because the first thing you see is a base. So let's do a conversion and see what happens. Again, this is how hard it is. Oops, if I can spell bay right. B to the E equals A.
Isn't that what you just did?
Yeah,
Oh, I thought we were converting it.
you are. What's the base of the logarithm going to be? 10. And even though it's understood, you'll always see me up here writing it down. Log with a base of 10. What's its argument or answer going to be?
X.
X equal to log base 10 of 4. And now this thing is answerable with pure common sense. For the left to be identical to the right, X has to be 4. There's a property over here that I meant to put on your form quiz, but I always keep forgetting to do it. It says B raised to log base B of X is X. Log. It was that property in one step. You had 10 raised to a logarithm of base 10. What's that property saying you can do with those things? No, look what it does.
Oh,
It's a straight up cancellation. If you have a base raised to a logarithm of the same base, chunk it. This just would have been 4, which is exactly what we got by showing all the hard work. Well, I showed you the hard work, hoping you understand the property. Or like, oh, I can do that. Let's look at this one from that same perspective. This is E with a natural log. And what's the understood base of a natural log? What's the understood base of a natural log? E, look at your notes, kids. Whose argument is 20? It's the same property. What's going to happen to that E in that log base E? It's going to cancel out. It's just 20. If you don't believe me, you can always push buttons. You add 10 roof-topped to the log of 4. It's 4. You add E roof-topped to the natural log of E. You have to raise that E to what power? Sorry, natural log of 20. Oops. That ought to be 20. I better use those figures. The one in the middle, example B, is a property that's on your form quiz that we'll talk more about either tomorrow or the day following. But it's this property. Log of A raised to the R is R log A. That is talking about how you can manipulate exponents of logarithms. In the form, what's happening to the exponent R?
It's just in front.
This gets shifted to the front. So anytime you see an exponent on a logarithm, where can you shift it?
In front.
The actual name of this is expressing powers as factors. That becomes x log base 5 of 125. And now you look at slide 3 where I was trying to teach you how to read logarithms. Slide 3 will teach you how to read logarithms.
That's fine.
If you don't do slide 3, you're going to have to set this thing equal to x, convert it into exponential form. What power of 5 equals 125?
That'll be 3.
That'd be 3.
That's easy.
So that piece, log base 5 of 125, is a 3. This ugly thing just reduced down into 3x. I don't think I have enough time to teach you inverses, so we'll start with inverses either tomorrow or Wednesday. Done. You remember, you have a test due to me tomorrow. If you're here tomorrow, that test is due tomorrow. Nobody came and asked for help during direct studies, so I guess you know everything.